Problem 169, majority element. In this problem, we are given an array of integers, and we have to return the most frequent element, the one that appears more than half of the time. In this case, that would be 3. So the majority element will always be present in every test. However, the way I'm going to write it, I will still want to have an option. If there is no majority element, I still want to return the most frequent element. And if there are multiple the most frequent elements, then we can return any of them. The way we're going to do this is, let's create a frequency map. So this will be a map where we will map basically each value to its frequency. Okay, so number to number. And it's easy to create this. We can just simply loop through this array, take each element, query the frequency map. If it returns undefined, that means the element doesn't exist. We can just put number 1. Then we go to the next element, do the same. Since it doesn't exist, we say frequency is 1. When we query the next element, it returns that frequency already exists. Then we can increment this frequency and basically do that up. So finally, we will get some sort of frequency map, which will have each value will be mapped to its frequency. Now, after that frequency map is populated, we can then go through the frequency map and just select the most frequent element. So select this element, the one that has the highest value. Okay, let's try to implement this now. Right, majority element. So initially, as we said, we will declare the map called frequency, which will be new map, number to number. Now, to populate it, I'm going to do a normal loop instead of for each. This loop will be slightly faster. So for num of nums, I am going to query the frequency map, frequency get num. So num is the current value that we are iterating over. So we get the frequency. I'm saving it inside a variable because I do not want to query this multiple times. So if it's undefined, I'll turn this frequency into 0 because undefined means the frequency is 0. And I'm going to actually add 1 to it. So that this frequency is now a new frequency of this value, including this occurrence that we have currently encountered. Now that I've calculated the new frequency, I can update that frequency set. For the num, we should set a new frequency that we've just calculated. Okay, so we've populated frequency. Now we should go through it. And again, I'm going to do a normal loop here. So value and frequency of. So if I iterate through frequency, this will behave in a similar way to an array of these pairs. So this will be an array of these pairs if I iterate over it. And then what I will do is, initially I will have, let's say, let me create frequency value, the most frequent value, and initially I'm going to set it to not a number. And then the most frequent frequency, This is horrible. Okay, the name of this variable isn't great, but this basically means the frequency of the most frequent element. So at the end of this loop, these variables should be set to, this will be the most frequent element, and this would be the frequency of the most frequent element. I won't need this value after the loop, but let's just set them both here. I'll just need this value to run the loop. Okay, so here, if this frequency of the current element that we're going through is better than frequency of the most frequent element, then let's save those. So 2 assignments at the same time. This would be value and frequency. Maybe I can rewrite this a little bit. So, okay, here I will do, well, I mean, technically we just say return frequent value. That's it. Here you can, in addition, say if this frequency, so this, the most frequent value's frequency is not big enough. So if it's not a majority element, which means it's not more, so it's, if it's not more than half, then we could throw new error and say no majority element. So we could do that, or you can comment this out. This is up to you. Let's try running this. Okay, try to run these tests. Okay, these tests are passed. Now let's do the actual submission. Okay. So, we didn't do very well. I mean, it's not the most efficient solution. So how should we improve this? One way to improve this is, let's say, create a variable here, majority count, and make it equal to num's length divided by 2, right? So now, if, while we are constructing the frequency, if majority, if our frequency is suddenly more than majority count, then we can return num. That will be the value that we're counting the frequency for. So at an early stage, while we're still creating the map, the frequency map, if suddenly we see that something is more than half, something occurs more than half of the time, then there is no way that anything else can occur. Okay, that works. Now submitting. Let's see what happens. Okay, I'm gonna try to rewrite this second part and see if that makes things slightly better. Probably not, but let's still see. So we have frequency, right? So I'm gonna take array from frequency and then run reduce. This will not be faster, definitely, but let's see. So I'm going to start from these values here, none and minus infinity. So basically, I'm going to turn this into a reduce. which maps don't have reduce method. So I'm going to convert this into an array, and then I'm just going to write it slightly differently. So let's say here I'm going to get, so best will be this pair initially. This will be this pair. And then as we're going to update best, it will be a similar pair of a value and its frequency. I want to have minus infinity here because any frequency, this should be lower than any actual frequency. So even 0 would actually be fine here, but let's put minus infinity since we have that number. So best, and then just next. So next will be next element from frequency, which will have the same form. So it will be an actual value and its frequency. So value from the nums array and its frequency, right? So now here, what I'm going to do is I'm going to compare and say if best one, that would be an actual frequency if best one is better than next one, that means we should return best, otherwise next. Comma should be here. So let me do this like reduce, just reformatting this a little bit. Okay, so let's comment this out. And now test it on our pretests. Line 24. Oh, right. So what I need to do is this will return a pair like this. And because I need a value, okay, let's assign this to something. So most frequent, and potentially I could do a check like this if I wanted to, but instead I will simply return, simply return most frequent 0, which means 0 is the actual value. 0 is this bit. And the most frequent 1 would be the frequency bit. Testing. Let's see what happens. Okay, these are passed. Now submitting. Oh, I forgot what the previous submission was. So this is like 6 milliseconds. What was the previous? Okay, well, anyway, we have these couple of solutions. A slightly slower solution would be probably to just sort this nums, take nums, sort in an ascending order, let's say. And then we could run a for loop through this num of this, right? And we could have a count. So similar to what we had, let freq value is not a number, and frequency is what? -1 minus infinity. This is the supposedly frequency of this value. Again, 0 is fine here. Now, what are we going to do is when we, or what's the hell, what is that? So if num is the same as freq value, then we're just gonna, okay, let's make it simpler. We're just gonna update frequency, right? If this is the same value, we're gonna update it. Otherwise, if it's not, then we need to make the following assignment. Frequency value and frequency would be, so value would be what? Of course, it's num, and its frequency is 1. Okay, so 2 assignments here. Now, we could exit early if frequency is more than, let's calculate the majority. Majority count would be num's length divided by 2. Now that's a fraction in JavaScript potentially, but that's fine. So if it's more than that, then we should return freq value. Right, so this one won't do. It will not return the most frequent element if majority element does not exist. Right, so here you could potentially say throw new error. Let's give it a try. This won't be faster, I mean, because here our time complexity has increased because we're doing sorting. Sorting is slower, obviously, than what is it though? Because I was playing with the map, so time complexity of the map. It's hard to say. It's hard to say. Let's see what happens. Yeah, well, we improved time complexity slightly. So we have, what is that? 4 milliseconds. Okay, let's have both solutions.